Welcome back to class. This lecture is the plumbing basic materials and systems. Hopefully this is enough of an overview that we can get into deeper things in further lectures. And let's get right into it. So today's lecture specifically we're going to talk drain waste vent, the sewer and septic, hot and cold water, roof or rainwater, how that's dealt with. We've talked a little bit about that already. And then the fuel gas, and we'll talk about hydronics. And I have something I hope you like at the very end, as that's not on here. So I think everybody kind of knows this, but the book was talking a little bit about the history, and I thought that was worthwhile to talk about and to bring up. And so you think of this photo right here of this old Roman lead pipe way back, and who knows when this was built. But if you're a history major, maybe you know. I like that. I was watching a documentary about Machu Picchu, and they had a plumbing conveying system, water and waste going carved into the rock. Pretty amazing. Think of European history in college, and some of the stories where they're dumping sewage and right in the streets, and sort of like the different pandemics that they had. Interesting. Anyway, there's a long history of sewage being dumped into water bodies like rivers and lakes and even the ocean, and causing massive problems there. And obviously that's still happening all over the world. And if you're getting your water supply from the same place that you're dumping your sewage, imagine the problems. But even closer to home, my wife's grandparents, who I love and adore, they're great people. They're in their 90s, and they have stories about having to get water from a well, and using outhouses and things like that, where there was no plumbing in their home when they were growing up as kids. And so is maybe there's a little bit of a time here in the beginning of the class to think we're pretty dang lucky to live in a time and place with plumbing, even though it's not maybe the most glamorous topic. It's super important for civilization, right? So let's start with the drain waste vent, right? DWV, drain waste vent. And we're looking at a plan view, right? So this is, in fact, this is from a previous lecture that we looked at a little bit. And I just mentioned it in a previous lecture, didn't go over too deep. But let's look at the drain piping, the waste piping, and the vent piping. So we have, let me turn this thing on a little bit. So here we on this heavy black line, and we're obviously looking at a plan view of men's and women's restroom. But this heavy black line, that is what is it? What they're calling it? Well, they're calling it 4-inch sanitary. So it's pipe conveying waste, and so you can see it coming all over the place in here. Now some of it's below ground and some of it's above ground. And this project, it's a slab on grade, so there's no basement or anything like that. There's no underground parking. It's just simple building, right? And so let's just kind of run through where the highest is. And you see this CO right here, 4-inch sanitary. It does not say that it is underground, so that's above ground right there. And what this pipe right here is picking up is the lavatory, right, where the sink. So the lavatories on each side, and they did a good job, in my opinion, of let's try and zoom in on that a little bit. So the designers did a good job of like drawing this in, and they spent some time actually drawing each individual little waistline there coming in here. And then over here in this area, they have 4-inch sanitary up. Well, that's basically saying that this is below slab, and they actually have it right here. Below slab, 4-inch sanitary. So if this pipe is below slab, this pipe is below slab. They don't have an up or down. And when you look at these drawings, they usually show like an up or down, meaning a stack in a circle. And you can kind of see that right here. So we have this guy right here picking up something. And what is that? Well, they actually labeled it well over here. It's a floor drain, 3-inch floor drain. And then what's this? So well, let's just trace it out again. We got the floor drain coming over here. If it's in the floor, this has got to be below ground. Below ground. Oh, there's another floor drain over here, and then it's going to come. So we can tell by the way this direction arrow, or the direction of this, I mean, there's other ways to tell, but this is an indicator of which direction this is flowing. So this is the highest part of the pipe. It's going to slope. I think it's usually a minimum of 1/4 inch per foot, and it could be more. And it's going this way and coming out that way. And so it's got lots of different branches. Want to spend a little more time looking at it. We've got this CO. What is a CO? And it says 3-inch sanitary up. What is that? Well, it's the end of the line of this, or maybe the beginning of the line might be a good way to say it, but it's a clean out. So we could go look at the abbreviation sheet for the plumbing and look exactly what that is, but that is a clean out. And we'll talk about clean outs in a little bit. This dash line, what is this? This dashed line. Well, 4-inch VTR. VTR is vent through the roof. And so right here, that's a circle. That means that goes up, straight up. And it could offset vertically, but generally it's just saying that that pipe is now going up. So let's try and trace that. This is the highest part. And so it's coming over here. It's picking up this pipe. Interesting. It's kind of hard to tell, but that's the 2-inch V up. So this is picking up some of the vent right there. And we see more water closets or toilets. I can never remember what water closet or lavatory. I always get them confused. They don't make any sense, those terms to me. So this is the vent. So the vent is not carrying waste. And the vent, so if we're talking, look it through this again, we have the dark line carrying waste, and it's sloped. And the plumbing line right here, this waste line, or sanitary line, as they're calling it, the 4-inch sanitary line, it's going to convey both. I'm going to throw a term out of this. Anything coming out of L1, that would be somebody washing their hands, and so that's gray water. And then the urinal would be wastewater, but they don't have separate pipes for gray water versus wastewater, so they're just calling it sanitary. All right, so what does a vent line do? Well, first thing it does is it vents the sewer gas from going into this space, and it's actually going above the roof. So this is vent through the roof. So this pipe right here where my mouse is, that's extending all the way through the roof, and that acts as being able to make sure that this waste line, the sanitary line, is vented out through the roof. And you think of the water closet or toilet, there's water in the bottom of the toilet all the time. If there was no water in the bottom of the toilet, you would be smelling sewer gas right here. And so we'll talk about traps here in a second, but that's how a trap would be right here. And that would be how there's no sewer gas coming out of this sink or lavatory, as well as the urinal. But in addition to just venting gas, what it's doing is it's allowing air into the pipe, and that sort of makes it so that it facilitates the actual conveying of the water. If you've had it has a lot to do with the pipe size. So there's lots of different various pipe sizes, and there's all different kinds of pipe too. But so depending on how someone actually ran their waste line and how they configured their vent, that would if it's not done well, you can actually hear it sometimes um, at whatever fixture you're at, and it kind of gurgles a little bit. It creates a little vacuum and tries to pull air out of from the from like I haven't seen it here, but I've seen it actually in a shower. All right, it kind of makes a gurgling sound when the vent or the pipe is not done correctly. All right, so we've got, again, looking at the whole system. We'll look at it here in a second, but piping materials can be for plastic, copper, cast iron. I've never seen steel be part of a waste system, but I assume it can be. I don't think. Let's just look at this as an entire system for a second. We did a diagram and looked at it from a schematic standpoint, but this whole thing is functioning together, right? We've got this piping is part of it. We've got a floor drain here. We've got waste lines for all this stuff, and think of this as a system. This whole area is something that if one part of it or one or more parts of it is not functioning correctly, not done correctly, it could make it so the whole system's not working. And so the cleanouts, these cleanouts right here and this cleanout right here. Notice that it's into this closet right here. It's probably a janitor's closet. And so the pipe runs all the way into this janitor's closet right here. And what they're used, there's a little brass cap usually on it or some other cap, and they can open that up and then clean out this line if there's some sort of obstruction in it. And these cleanouts are tremendously valuable. They really are. Think of a couple different projects where we had an assisted living project that was a brand new project, and we kept coming out for warranty calls, and the warranty call was that somebody's drain wasn't draining, and I think in one case there was gray water backing up into a shower, and so, well, it might have been just wastewater, I don't know, but there's water coming back up the drain. And so it was a multi-story building, and you think of like the head pressure. If there's an obstruction, the water could back up in the pipe and then go wherever the lowest pipe is. So if there's water above the floor level of your shower, you'll end up getting water in your shower if that's the way it is. And so these cleanouts are tremendously valuable. And it turned out that somebody was putting some material down the drains that they weren't supposed to do, and once that stopped happening at the assisted living center, we were stopped getting called out. So some common problems as well for you could have a broken pipe. So think of during construction as well. These plumbing cleanouts are really worthwhile. So if during turnover or something like that, I've seen it where one of these pipes during construction got ran over and ended up breaking or flattening and filling with material, and so these cleanouts become really, really valuable to find out where that is, and so you can go isolate that location, dig the floor up, and hopefully that doesn't happen, but it's pretty common. So these cleanouts, I don't want to spend too much time on them, but in my career, they've been very valuable to make sure that they're there. So I keep an eye on when I'm on site, making sure that we got cleanouts. Okay, so I was talking about the lavatory and the toilet. The toilet has its own version of a trap, and so if we're looking at some of these components from the previous drawing, we had drain waste vent, we had a floor drain, we have cleanouts, well, I didn't get a chance to show in that last drawing because they aren't drawn very well. Or they wouldn't, I shouldn't say that because you wouldn't want that drawn there. Traps and fittings aren't typically drawn. And there's all kinds of fittings. Not going to spend a whole lot of time. Some books cover it a lot, some books don't. It doesn't matter to me a whole lot about the fittings, exactly what fittings being used. I just care that it ends up getting tested right. But the trap, it is a good concept to understand, right? So if there's a sink up in this location and here's your waste line going out over on this side, the trap fills up with water or waste water. And so the it levels out, right? The trap level, water seeks a level, so it's going to create this little uh, area full of water at the flow line of the pipe, and that will then trap the gases from this side from getting back into, say, the sink or the toilet or whatever. So going back to a previous one, a common problem is if this restroom got built and say the building didn't get occupied right away, in dry climates, these traps on the floor drain can dry out. And so you can end up having gas being coming through this area right here and coming right out of the floor drain. And so I've been on lots of projects where an area was decommissioned or something like that, and some of the first areas that the traps dry out uh, is like the floor drain. It's rare that I don't think I've ever seen a lavatory or a toilet dry out, uh, but I have seen lots and lots of drains. Because when do they actually get a bunch of water, right? So they get water when someone cleans the floor or there's a problem. So that's when it gets water. If the area's been decommissioned and isn't getting a lot of washing down, that's what you're going to have. It's a bunch of sewer gas coming into this space. So that's the value of a trap. So let's just talk drain pipe size. So 1 1/4 is typically the smallest, and I don't think I've ever seen 1 1/4 really be used anywhere other than by a sink. So in a residential environment, but all piping is usually bigger than that. And so, but I do want to talk about the idea behind pipe size for a second, and sort of the philosophy behind it. So the water, then it needs to, the pipe's going to slope, right? The drain pipe is going to slope, and it needs to have enough water in it to carry solids. So it needs to be probably, by rule of thumb, that by design, if we did it right, it would be about 1/3 full of water, and this would be airspace up here. The drain pipe is not supposed to fill up with all the way to the top with wastewater at any time. It's not supposed to do that. So as you get higher up in the building, usually the pipe size can go down. As you get farther down in the building, the pipe size is going up, and because the idea is you have these fixture units, and the more fixtures associated with that pipe, the larger the diameter needs to be. So you might think, hey, bigger pipe, let's just do it all over the place. Let's just do that. Well, that's not a good thing either, because you do want enough water in the pipe to be able to convey the solids, and it's something they call scour. They want to be able to have enough water to scour the pipe. And if you have too large of a pipe, you'd have less, I don't know what the right word is. I think the volume would be basically the same, but you don't have, the solids will begin to slow down because they hit the bottom a lot, right? And so you don't have enough suspended, I don't know, maybe that's the right word, enough water to be able to suspend the solids and be able to scour that pipe and carry the solids, right? And so as you go down, as the pipe ends in a wall and goes down, I called it a stack, but I think it's interesting and good to know that the water, again, there is not, it's not traveling in like a big slug right down the middle. It's actually going around the perimeter of the pipe. And air is come as water goes down, there's actually air in the center of the pipe. And so that these, as this is sized, and there's all kinds of code stuff, I'm not going to cover that. I don't, from a general contractor standpoint, very rarely get into that, so I'm not going to cover it now. And but anyways, the stack, I think it's appropriate to know that. Now, on smaller projects, light commercial, residential, oftentimes the piping size for sanitary sewer, for drain waste vent is not sized. It's not called out, right? So the plumber has to get into the code and figure out how many fixtures are on this, do the fixture unit calculation, and figure out the pipe size. So on larger projects, the designers should typically throw that on there, and we saw that in the previous drawing where they actually showed the pipe size. And let's go back. Let's look at that. Right. So they're calling it out here. 4-inch vent through the roof. That's the pipe size. 3-inch. That's the pipe size. 4-inch sanitary pipe size. And so this is 4-inch. Here's 1.5 inches. Right. So they're on, this is a commercial project. It's not super big, but it's large enough that the designer spent the time to diagram out the pipe size. But the point being, the plumber on the residential side or light commercial side would have to go figure that out. So there's something that I think is worthwhile bringing up, that, and I think this is a good sequence issue. So in the previous lectures, I've talked about coordination, sequence, things like that. But as what is this thing? This is some sewage pump. So sometimes the house, the building where the plumbing is coming out of the building is lower. The plumbing's coming here, but the sewer main in the street is actually higher, and so they'll install a sewage pump. So let's just go look at that for a second. I think this is worthwhile. I want to do this little exercise. So I got online and I just wanted to show you a resource, and I do this frequently, so this is a good strategy. Okay, the drawings call out a sewage pump for the building. It might have a model number, it might not. And let's say I'm new in my career, I don't even know what this thing is. Home Depot, lots of websites. I'm going to show websites today because I think it's a good resource. Should be Googling lots of things in this industry to try and understand it. And heck, if I do it every day, I'm going to show it in the class. I do stuff like this all the time.
Today we're going to discuss the Everbuilt 1/2 horsepower pre-plumbed sewage basin system. Before I begin, I would like to advise you to make sure that the installation of this system will meet any and all of your local, county, or state plumbing or sanitary codes. The system comes pre-plumbed. All of the internal plumbing has been done at our factory. The system features an 18-inch by 30-inch structural foam injection molded basin. The basin is heavy duty. It features our 360-degree easy grab handle that allows for easy carrying of the product wherever you need to set it. First thing I'm going to do is reach in to the factory pre-punched inlet hole.
That looked like that kind of hurt.
That hole is set at the industry standard 10 1/2 inches from the top of the basin rim.
So that's where,
inside of here I just grabbed out.
That's where, if I needed this system, I have a floor level. Let's say I'm putting this in a home with a basement, very common, and the sewer line is in the street, either a greater distance or it's above. Once you try and get the appropriate slope out to the sewer, we're not going to hit our line's going to be lower than the sewer line in the street. So this would be the floor level of the basement, where you got to build maybe down a little bit more even. I've seen these down in a pit actually on a commercial job. And so, but that right there, that's where the sewer or the wastewater would come in right here.
Is from the top of the basin rim. Inside of here, I just grabbed out the accessory package. We're going to set some of the accessories aside. A 4-inch pipe collects your wastewater from your toilet. We provide a
Yeah, I kind of
watertight
talked about
as
that.
well as a gas-tight seal to the
And he's going to
4-inch
talk about how the pipe gets
use of a
installed with
lubricant or another
lubricant.
distance during shipping.
Okay, cool.
Once those are out, we want to reach our hand in the 4-inch inlet and grab the 10-foot pump and piggyback float switch cord. You want to grab one of the cords, pass it through the cord grommet hole, pulling all of the slack, reinsert the pump in time to make the taps of a rubber mallet will assure that as well as plumber's putty.
All right. Okay, so this thing's got a pump in it. It's got wastewater coming in. Obviously, one of these is going to be vent, one of these is going to be out.
Plumbing the system as simple as that. Included in the accessory pack is the Everbuilt 2-inch heavy-duty ABS sewage pump check valve. This is a compression fit check valve and it will pass a full 2-inch solid. This check valve is installed at the appropriate location on the discharge line.
You guys follow that? They're basically saying that it's a one-way valve. If the wastewater gets pumped up, you don't want it to then immediately come back down into that basin and start the pump cycle again. So that check valve's making so that it doesn't come back. Anyway, I do stuff like this. There's no way to know all the industry stuff in our industry. So heck, this is just an example of stuff I've done in the past. There was one point in time where I had no idea what a submersible pre-plumbed sewage basin system was. Heck, a little bit of Googling. Home Depot's got a nice little video. Hopefully people aren't too mad that I showed that. And I snipped the Home Depot image just to show what the pump looks like on the inside. There's obviously no opening like that in the system. But so this is, if we're talking about that previous drawing and going into what the next topic is, what coordination issues do you see? What sequence issues do you see if we needed to build a home or a commercial project with a sewage pump? I'm hoping that you're thinking, well, underground plumbing's typically, we've got that below the slab normally. Well, I'm hoping you're thinking, well, we better measure the flow line of the sewer and check that against the flow line of our waste coming out of the home or the commercial project. Sometimes those are not calculated right on a residential project that's got 8 pages of the drawings. You're never going to see that calculated for you. So you got to go get the flow lines and do the math to see if it's going to work. You get the plumber involved, maybe utility contractor if you need some help. But I'm hoping there's some coordination. So if that needs to be done, we need one of these things. And so there's concrete, locate top of slab would be here. And so what are we going to put around this thing? We got to dig it out. There's excavation. There's a bunch of little things going on for coordination that needs to happen. There needs to be an electrical source nearby, right? All right, cool. So if we get back to this idea here and thought through coordination logistics, in the previous lecture, I showed that there was a footing. There was a footing right here. And so we would have wanted to coordinate this line because it's below ground. And we wanted to make sure that if we talk about coordination with earth, and if we got to dig this right here, where are we going to put the spoils? We've got pipe that we've got to coordinate in this wall. A little bit of finishes to coordinate right there. So the slab on grade floor finishes. So we've got to place this floor slab in these restrooms, and we need the floor to slope to this drain. So there's a little bit of coordination that needs to happen with the height of this drain to be set, the floor drain, because we want the floor to drain to it. Now imagine for a second that we decided that we are going to slope from this corner and this corner over to here. That's a pretty dang long run. So how deep does it need to be? If we didn't do this right, you could also have uh, a pool of water right here on this wall. So you got to think through those kinds of things with where this plumbing is going to get set. Make sure people are coordinating. Make sure that what about the wall finishes and things like that. So if we had a clean out on this wall, but we ended up having maybe like this looks like there's some sort of mop sink, and a lot of times you'll have a um, like a FRP panel in this entire closet. Maybe we need to do a little bit of something there to make the clean out work so that we don't have anyway, wall finishes, a whole bunch of stuff with fixtures to coordinate. Anyway, I don't want to spend a ton of time, but I did want to talk about that. One thing I think it's worthwhile talking about when we're doing underground plumbing is pipe bedding. So some areas you can use the native material as bedding, and a good example would be if you're in Utah, anywhere near the Weber River as it comes out of from Morgan. There's just a huge sand pile there, and certain areas of the state have a lot of alluvial or river deposits, and you can use the existing material as bedding. But quite a bit of area is actually quite rocky or too clay, and they need to bring in sand or pea gravel to be able to bed this pipe down into it. So when I'm saying bedding, they got to lay this pipe that's underground, this one, on something, and they got to get it to the right elevation. So the excavation usually is just a trench, but then they put in sand or pea gravel or some other material to be able to create the elevation for this pipe to sit on, called bedding. And they usually use sand or pea gravel because it's self-consolidating. Okay. So if we're talking some of the things we've talked about in the past, what's the sequence? Deepest to shallow, right? So say we coordinated this footing, and the footing that's what is here is gone. Well, deepest to shallow might mean that you're going to start down here over on the side of the building and dig this way. But the waistline might not be the deepest thing, but it's definitely going to be one of those things that you need to think about. It usually is one of the deeper things, but it might not be. So in the wall, we've got to think about how we're going to do this. Are we going to do the studs first? Are we going to put the piping in first? Is there a big, they have some things where they prefabricate all this piping right here and put it on a skid. And it's a nice way if you have a lot of these in a building to be able to do these quickly because there's a lot of piping right here. And so they could build this entire piping system on a skid in a shop and then bring them out. And if you're doing that, then you definitely don't want the studs there. So thinking through some of the sequence, I listed the common ones again, right? Remember, sequence is most often deepest to shallow. Plumbing would need to go before electrical. And so the highest, work highest to lowest. So this is something that's high, and it's going to go all the way to the roof. But obviously all this can't be done at one time. It's going to be coming in different phases of the project. You're going to do underground plumbing, pour a floor slab, and then you're going to be doing something else like walls and in-wall plumbing. Eventually you're going to be going through the roof. But I'm going to bring that through. All right, I want to talk about common coordination issues. And let's go show this and this. We already looked at it. Yeah, let's go look at these in Bluebeam in their drawings. And we'll look at fire rated assemblies on this one. So Hilti's a fire stop, I think fire stop. Oh yeah, it's right there, fire stop. Hilti manufactures a bunch of this. But if you have a common issue is the fire rating penetrations that plumbing causes. So if you have say a multifamily project, and let's just go bring that up right now. But think through this detail right here where you have a pipe going through a wall, and they've got 2 layers of gypsum that needs to be fire stopped around it. And so that's what I'm kind of talking about, is a pipe going through the wall, and it's a fire rated assembly. The wall is. We're looking at the multifamily project that I bring up frequently. And so just sort of look at this as the second floor of this series of apartments or townhomes or something, right? And so let's just look at, this is the second floor, level 2. This is the third floor. And let's just pay attention to the last unit. All right, here's the third floor, here's the second floor. On the third floor, we got a bunch of plumbing right here. So we've got drain waste vent that needs to get to the sewer. How is it going to route? Well, you can't go this way necessarily because you're going to be in an exterior wall. And if you did that, you can't put plumbing in an exterior wall without... Anyway, that's not a good route. So you're probably going to come over here, try and get in this wall. This wall is fire rated because there's 0 lot line between the 2 dwelling units. So this right here is a fire rated assembly, and any pipe penetrating anywhere in there would have to follow that detail. And I bring it up as a common issue is because I don't think it's well understood in the construction industry really by any trades, and but that really understand well the fire rating system. So plumbers, they know lots and lots of good stuff. And I love the plumbing trade. They're great folks. They frequently put holes into a fire rated wall and got problems there. So they don't necessarily put holes in there, but they're putting pipes into a space where there's it's a fire rated assembly, and unknowingly creating issues for the trades farther along. So that was one issue: fire rated assemblies and penetrations. I said pipe locations with foundations below. Let's bring up Navisworks and let's go look at this project from below. Ooh, coming out of the sky. Cool, look at that. So all these green things, those are all footings. We've got below slab plumbing here, maybe a little bit of a conflict there. We've got all kinds of plumbing line. These are probably electrical lines, my guess, but got plumbing all over the place. So does it coordinate well? This whole area seems to be just fine. We go grab that guy. Well, we're getting close there. They're going to get it. Let's go look at this. That's probably electrical. So we've got a lot of stuff underground underneath this building that is got to be coordinated. And I bring this up, I think I brought it up in my first coordination topic, was underground plumbing as a good thing to understand that we need to coordinate. But I think this is a good view that you can kind of see there is footings and there's all kinds of stuff underground. And I think it's commonly missed, meaning that out of sight, out of mind, maybe. I don't know. But maybe it's more common to think through the coordination of the in-wall. I don't know. But it feels like this is a common issue that, one, the designers don't necessarily collaborate early on and think through, but underground plumbing and and whatever else is below slab oftentimes are in conflict. All right, let's go up. Let's see if we can get this thing to. Let's try and walk over to where that plumbing is. Aha! Plumbing. It looks like we're still. There we go. All right, cool. We are in what appears to be some sort of locker room. Yep. And there's some urinals there. So let's just talk. Let's do this. Navigate right into the wall. Wall right there. Cool. Isn't that amazing? They put the pipe digitally in the wall. And does the pipe fit in the wall? It's so common that the piping, remember how as you go higher, the piping can shrink because there's not as many draining fixture units, or farther away or higher, as more fixtures get onto the pipe size has to go up. And so if you know that that's kind of the rule of thumb, just go try and find the piping that's farther away and go look at your wall types and see if the plumbing actually fits in the wall. And it's pretty common that it does not fit in the wall. So that's another common issue. Now this is let me go back to Bluebeam for a second. Let's bring up, let me put this, now we'll just draw it. We'll just draw it right here. Let's say for a second, let's just say for a second we've got this arrow represents the drain line coming down the wall. And we've got, it fits in the wall. That thing's going to be our okay. That's the sill of our framing. Here I am trying to make this thing like perfect. Okay. We got a pipe coming down a wall. Now let's say this is a bearing wall. And so we'll draw in subfloor. Whoop. There's the subfloor. And let's say, for instance, we got a glue lam beam holding up these joists. Hopefully you see the assembly that I'm trying to draw here. All right, that guy right there is our waistline. Whoop, that's not what I wanted to do. Sorry, guys. So this is really common that there is coordination issues where you have 2x4 wall or 2x6 wall, doesn't matter, maybe it's the pipe fits in the wall, and it's 2x6, and that's it's bearing, it's a bearing wall, and right below it is the rest of the structure. So how is this pipe going to get through this and back into the framing that's below it? How are we going to do that? Well, that's going to be a real challenge. It really is, and it's pretty common that you have these kinds of problems right there. Well, I was trying to draw that as the anyway, harder to see. That's one issue. This could be replaced with an I-beam as well and a concrete deck. And it's super common again where you have steel studs just happen to line up with an I-beam down below. Maybe there's a concrete slab on deck, I-beam right below, and you've got the expectation that the plumbing is going to go right through. Common coordination issue. Okay, so the plumbing issues that frequently happen are when you're trying to get you have say you have a cabinet right here, and the plumbing is going to have to come up this wall, the drain waste vent, and you're going to have to get it all the way from here to there. Well, you have something in the way, like a stove. Well, that's going to be really a challenge to get something over here. So you have to figure out a different route. But one of the specific things when you get into cabinets and floors that don't stack vertically. So look at these two floors right here. How this is level 2, this is level 3 of the same unit. This is right above that. And it can be a real challenge getting the plumbing to line up exactly right, especially when people are making changes in the drawings. So imagine a plumber, and there being a cabinet right underneath here. This is a perfect example too. Let's say the plumber split the difference and put the waste vent right here, the waste line right there, and that could be the middle of two cabinets. And if he does it right in the middle, then as it comes out of the wall, the cabinet is going to get split. It's not, so it'll have a drawing over here. Let's say you had another cabinet over here, and I know that there's drawers in here, but that's not making sense. But here's a sink. I just picked this up just to try and show it. There's a sink next to each other, kind of like this is what I was trying to draw. And the plumbing comes and hits the midpoint and busts out like that cabinet wall right there, and it just looks terrible on the inside. So as soon as somebody opens up the doors and things, it just looks awful how destroyed cabinets can be because of how the plumbing was routed. And it can be very difficult. So spend some time coordinating that is worthwhile. Okay, moving on past coordination of drain waste vent, let's get into testing. And so we need to perform a test, and we talk about the jurisdictions having authority. This is in the commercial side here in Utah. It's very common to see someone, jurisdiction require a test like this be witnessed by one of the jurisdictional authorities. And so I don't know on residential whether this is super common to be inspected or not, but on commercial it is. So but we need to be testing the line before it is covered up, concealed, typically meaning before you put insulation in the wall. And this is a good point. So how this works is you have a picture of just this little balloon that gets put into the pipe, and you usually put that at the floor line. And say you're trying to test that multifamily building, and you want to test the third floor plumbing, make sure that it's going to pass. You would put this in at the floor line of the third floor and the waste line in the vertical stack, and pump it up, and it create a blockage. And then usually you do that. You take the clean out of the stack and put that above the clean out. So it goes, you put it up the pipe vertically, and then pump that thing up with a little compressor or something, and that creates a blockage. And then you can fill up the drain waste vent, fill it up with water, and generically, don't remember now off the top of my head. Let's see if I made a note for it. My memory says you have to have 5 feet of vertical water head to be able to pass the test. And it has to stay there for like a while, maybe 15 minutes, I think, is my memory for residential. Might be more for commercial. But this is the point of doing this is I don't want you to remember all these little code things. I just want you to know that you're talking through drain waste vent. This is something that has to be done at the end of the task before you can cover it. And this is a great topic to be talking to someone. So meaning if I was talking to the plumber and I wanted to know from a general contractor standpoint, I'm trying to schedule and figure out when to do things. I would not ask him a question like this. I wouldn't say, when is your piping going to be completely installed? That doesn't answer the question as to when it can be covered up. I might, if you add that on there and say, when are you going to be completely installed with drain waste vent and tested on, say, the second floor of what I'm trying to cover? That's a different question than when is your piping going to be installed. So that's a critical thing that if you can account for and make your conversation about these capstone activities like testing, a capstone activity being like once you finish this, then you can really move on. But some folks really just say things in a general sense of when is it going to be completed, and sometimes I think folks take advantage of the other folks and don't tell the truth and know that they still need to test, but they'll talk about, well, we'll be completely installed by this date. But that doesn't mean you can cover it because there's another test, another activity afterwards. Hopefully I didn't belabor that too much, but that's really important. If you're working in the industry and you want to be a good at mechanical electrical coordination, do not use install as the final activity. Use testing as the final activity, whatever it is. Okay. Let's move on to sewer and septic. They're not going to be too deep here. So I think everybody knows what a sewer main is, right? I'm hoping anyways. And I don't have a lot to say about the sewer main because this is mechanical, electrical, plumbing. And I already said it in that the coordination issue is really trying to make sure that the sewer piping on the outside, which is designed by the civil contractor, and the plumbing waste line designed by plumbing or mechanical designer. I'm not sure exactly who actually does that sometimes, but mechanical engineer almost always. So anyways, the point being, having those coordinate is the issue, but the septic system's a little different, and I'll tell you about that in a second. But one thing I wanted to bring up that is super common is blockages in pipe, and I already talked about it from a cleanout standpoint of someone putting something in a finished product, like I said about that it was a assisted living place that they're putting things down the drain, and then it clogged the pipe and we constantly coming out for warranty. Well, this is even more frequent, and I got to tell you, construction is hard on the materials that are placed. So you say you have like this stack coming out of the ground or something like that, and we're still doing earthwork or we're still doing something else, man, this stuff just gets damaged so quickly. And so think of what's now down in this pipe if this got hit. Well, I don't know what's down there, but you can see something down there right now. And so it is really common to have somebody knocked into this pipe and it's broken, it's cracked, somebody knocked into the top and dumped a bunch of material in it, or somebody's dropping their trash down there. Somebody's trying to throw gravel all around here and the plumber did not cap them and it's getting packed full of gravel. Or worse yet, this is there and it's open during placing of a floor, and I have seen that so often where concrete goes down in the drain and it is down there and no one knows until after you get a warranty call. So this is what it looks like when this is a roof drain pipe going to the storm drain that is blocked. And I talked roof drain and I'll talk about it later, but I didn't have a picture of sewage, but I had a picture of during construction, the roof drains start to get hooked up on this building. Our piping down below this level is blocked by gravel, and some other dirt that pipe got filled up with. And look, we get a rain event, and the roof and the water on the roof comes down, hits that pipe elevation, and then backed up into the garage. This is not rainwater that came into the garage. This is rainwater that came down the roof drains and backed up into the garage because that's the level, that's how much water was in that pipe. Just needed to go somewhere, and this is the lowest elevation it could come out. Pretty interesting stuff. Got to pay attention. So, what is a septic system? Typically, most municipalities are sending the sewer, the wastewater to the sewer, and some are going into a septic system. And I think this is worthwhile showing a septic system, a typical septic system. And so we have our wastewater from our house or small commercial project coming in here. You have the sludge filling up down here. You have these little baffle systems in there to be able to keep the things that float on one side, and you keep the sludge on the other. This will eventually have to get cleaned out. But then you get some fairly clear water in this location, and the clearer water will come out and go to a leach field of some type. So that's your basic septic system, and you can see the access covers and stuff, and they'll eventually have to clean these out and stuff. And I don't want to get into the microorganism stuff that breaks down all the stuff, but anyway, lots of cool stuff happens on a chemical reaction level or microorganism level. I'm not that type of person. I don't know all those details.